Okay, welcome everyone. My name is Henrik Engstrom. I'm here to talk to you about reactive applications and using Play, Akka, and Scala to build such applications. I work for a company called Typesafe, and we're the company developing Akka and Play and Scala as well. So here's the agenda for today. I'm going to give you an overview of what reactive applications is. So it consists of 4 tenets. I'll go through those briefly. I need to warn you that you'll not become an expert in these 3 hours. We're going to cover a lot of topics and skim through those. But it's important to understand that you won't be a reactive application expert after these 3 hours. So it's going to be a whirlwind tour of Play and Akka. We're going to use Scala. Hands up, how many have used Scala before? Okay, so maybe 20%. Akka? Anyone used Akka before? 1.5. And Play? Okay, so maybe five persons have used Play before. I'll take you through these tools. Of course, they have a lot of functionality in them, so I won't be able to cover everything. So it's going to be some theory mixed with hands-on coding. You'll use Activator. I'm going to show you how to download that later. And hopefully, if the Wi-Fi permits, you'll be able to download the tutorial. Otherwise, I'll show you as well. I'm going to do some coding up here as well to show you how to solve things. But it's going to be like a mixed theory and practice. So what we're going to do today is build a reactive application, of course. We're going to start off with a basic non-clustered solution. That's going to be implemented by you. I'm going to drive you through and tell you the different concepts that consists of. And then after we've done this basic non-clustered version, we're going to create a clustered one as well. And that's something I'll do from up here. So if you want to get an in-depth knowledge of Akka and reactive applications, we actually have, let me go back, sorry. We have in the room next door, in D134, my colleague and I are having a 2-day session where we'll go through Akka and reactive applications in depth, and we'll cover this. So if you want to really learn Akka, then I suggest that you walk over to D134 right now. You can also join, of course, after this is done, join after lunch. Duncan right now is talking about reactive applications, and then we're going to show Akka and a lot of concepts in there. So, this is actually a great, it's actually our training material for the Akka course. So if you want to learn Akka, that's the place to be. But of course, I want you to stay in here too, so yeah. Okay, so we're going to start off by downloading Activator. I know, has everyone downloaded Activator? Yeah, so you have Activator installed, good. Okay, and now when you have that, we are going to download a template. Unfortunately, you can't see because it's too small up here. But if you start Activator by running the Activator UI command on your machines, it's going to open this splash screen. And in this splash screen, you can search for an application called Reactive Instruments Workshop. There's a search window up there. So if you type in Reactive Instruments Workshop, you'll see that tutorial, and then you click and create that locally. So that's something I want everyone to do. Hopefully the Wi-Fi will permit. I'm going to keep this slide for a minute so you can type in. So start off by running Activator. That's going to open the browser for you, your default browser, with a splash screen, and you can enter this Reactive Instruments Workshop. And then you click Create, or Create App. And when you do that, it's going to download a whole lot of things and create this somewhere on your disk where you select to create it. We're going to use this template. It contains some functionality, and then we're going to evolve that functionality to create the reactive application. So if you want to be able to do this on your machine, this is what you should do. The reason I couldn't send out the instructions for this before was because it wasn't created. If you get an error saying could not load build configuration, just click proceed and hopefully that will work. It's going to take a while because what's happening here is it's downloading the template code, and then it's in Activator is going to try to compile and download all the dependencies for you. So basically, Activator, for those who don't know, is we have created a build tool called Scala Build Tool, SBT. Activator is basically a layer on top with the UI associated with this build tool. And in our tutorials, we have defined the dependencies, sort of like Maven, but it's SBT and Ivy. And it downloads everything for you, and then the Activator UI is going to compile this project. And in Activator, you can then use Activator to develop. There's this small code editor in there, and you can also run your application from inside the UI. So, it didn't compile. Are you using Java 8?
I think 1.7.
Okay, so it requires Java 8, unfortunately.
Oh,
yeah.
Let's see if I can set that.
Yeah. What's that? Okay, yeah, that's bad. Can you try to restart Activator and try it again? Okay, if it doesn't work, I mean, it could be the Wi-Fi is a bit flaky, I guess, so maybe it is not able to download everything. Has anyone been able to download and have this compile? Okay, so we have one person. Awesome. It's compiling? Okay, so maybe it's going to take some time because it's, yeah. If it doesn't work, I'll just drive everything from up here, but hopefully you'll be able to try it out on your machine as well. Okay, so I'm going to switch. Yeah, as I said, with Activator, actually this is a good time to actually run this. I'm going to switch over and run Activator myself. Download. Okay, so I'm starting Activator.
Is there a way to select the template command line?
You can create it from the command line, yes, but you can't select it when you start Activator.
It's not coming up in the search.
Okay, I guess that's related to the Wi-Fi again. Sorry about that. If no, you need 1.8. Yeah, I get the same thing with the Wi-Fi here. It times out for me too, so that's bad. Yeah. Okay, so I'm not going to show you Activator now because it doesn't work. Instead, I'll go back to the slides and just tell you that in Activator you can build and you can develop code and you can run and test. And I'll let Activator work in the background for you guys. And if it doesn't work, I'll drive everything from up here. Basically, what we have, let me talk a little bit about the reactive applications then. Reactive applications consist of 4 different traits. And they are message-driven, resilient, elastic, and responsive. And I'm going to explain to you what these are. So there's this reactivemanifesto.org where you can surf into, and it explains the reactive manifesto in detail. But basically, what you want to have when you build a reactive application is that the application fulfills these 4 traits. So first of all, users today expect that your system is always responsive. If it doesn't reply back within 0.5 seconds or less, then they get bored and go somewhere else. So it's very important to, of course, have a responsive system. That's like the topmost trait, what have you. And to create a responsive applications, you need to make your system resilient. And what we mean by resilient is that the system should work even if nodes go away. If you have a crash, a machine crashes, your JVM throws an exception, out of memory exception or something similar. Okay, there you go. So reactive opened after a while. And so resilient is very important. It should handle failure. You know failure is going to happen. When you have multiple servers out there, I mean, if you have 10 or 100 servers, you know failure is going to exist. So therefore, you need to implement your application to handle this failure rather than being surprised by it happening. So that's a really important trait as well. So I talked about different nodes or different machines, and that ties into the elastic trait, where your application is implemented so it can be spread out over multiple machines. Because if you only run your application on one machine, then of course if that machine goes down, your system will stop working. So it's important to build a system so it can scale out over multiple nodes. And that's also a way to keep your system responsive, of course. Because if you have a heavy load, you need to spread out the workload over machines. And the final trait is message-driven. And message-driven is what enables these other three traits. It's basically that your system is implemented in an asynchronous message passing way. And you might have guessed, but Akka is what drives these traits in combination with play. So that's a perfect fit for reactive applications. Akka, I'm going to go through Akka in a bit more detail, of course. But that's basically using message passing internally. Okay, so today we are going to build this reactive instruments application. And basically what it consists of is that you have your browser, and that's going to call play using WebSockets. It's setting up a WebSocket, calling the play server. And in the play server, we serve the incoming JSON requests. First, of course, we set up this WebSocket communication, and then we serve any incoming request. And we're going to fetch some prices from a remote server. So it's like a microservice application. And that's already provided for you, this HTTP microservice. That's basically just replying back with a randomly generated price. And then we're going to create a clustered version of this price service in step 2. So here's what it looks like if you look at the boxes or the architecture. You have multiple browser clients that call into this play server. Each of these browsers sets up a WebSocket. Internally in the play server, we're then going to use Akka actors, or one actor rather. And that actor is going to call this price service. So it doesn't really know what's going on in the Akka HTTP service, that it's Akka. Or it's just another REST endpoint, basically, that we call out, get the response back, we parse that, and we push it out to the browser. So that's what we're going to build. Okay, so let's talk a little bit about play, or maybe I can jump over at this point and see if we can open this. So here's the Activator view. Activator is going to build this for me. That's in the Build tab. Here I can select when it's not running. It's restarting or when it's running. I can select to compile and clean the project. And then in the code view, it's just like a file browser in here where I can open up the source code. Maybe I can increase the font a little. Can you see this from? No. I guess not. Let's do extra large. Extra large. Okay. Basically, you can just look at the source code here. You can, of course, change the source code, and then you can go into the Run tab and run your application from in here as well. Now, if you downloaded this Reactive Instruments workshop, of course you can use your IDE to implement this too. If you use IntelliJ, for example, you can just open it and it's going to create the project for you, and then we can, inside of IntelliJ, develop the application too, or Eclipse, or whatever is your preferred application or IDE. I'm going to use IntelliJ, and I guess a little bit about of Activator, if Activator turns out to be able to compile this. Yeah, as you can see, it's now compiling the project and setting that up. It's slow because the network is slow. Okay, so let's start off with Play, this first server box on the slide before. So we had the browser clients calling into Play. And Play is a web application framework that's inspired by Ruby on Rails. And that is that it's very, very developer friendly. We think it should give good error messages if there's something wrong in the application. So you don't have to actually look what's wrong. It should provide very good information out of the box. It's a containerless implementation. So it doesn't use servlets or anything. And that's to ensure a synchronous and non-blocking threading model. We do believe in statelessness, so there's no statefulness in Play. It's Typesafe, and it does compile time checks of configuration and code, and this is really important. So when we wire our routes, I'm going to show you that later, of course. Yes, question. What's that? The slides are online. Yeah, I uploaded them yesterday. So if you go to, I don't know if they've published them yet, though, OSCON, but I uploaded them yesterday. So they will be online, of course. I don't know if you can find them right now, though. Probably not, because the Wi-Fi is not good. Okay. Yeah, it compiles your configuration as well. So if you set something incorrectly in your configuration, then Play will warn you about that, saying, I can't find this controller, for example. So that's really convenient when you develop. It thinks of the developer and tries to help you as much as it can. Another important thing is that it's usable from both Java and Scala. Although Typesafe is, we developed Scala, we believe that all our tools should be usable from both Java and Scala. We realize not everyone's going to switch to Java, so it's very important for us as a company to support the both. And the same is true for Akka. So Akka, you can use both Java and Scala. Okay, so now we're going to run Play, and I'm not sure if you've downloaded, if this has worked for you. But basically, if you've been able to download a tutorial, then when you run it, yeah, it doesn't work for me either. That's a bummer. Okay. Let me see. Sorry about this, guys. So yeah, just this reactive workshop, instrument workshop, it's a GitHub repository that I have on my GitHub account. I'm going to give you the link to that. It contains a couple of steps. Each step is the solution for the steps I have in the tutorial. So if you want to check the solution later, it's all available in the GitHub account. Okay, so hopefully this will work. So what I want to do now is basically, I wanted to use Activator UI to start and to show you that you can run the Play application from inside of Activator with this Run tab. but since it doesn't allow me to start Activator, then maybe I can use SPT directly instead on the command line. That doesn't seem to work either, and then we're more or less screwed, which is bad. Because then I can't compile stuff. Okay, I'm going to give that a second and see if that works. Meanwhile, we can go through the setup of the Play application. I told you before that Play application consists of, it's a containerless implementation, which means we don't have to follow any rules or anything for how servlet should work, the traditional Java applications. So it's got its own structure for where the files are. So if you look at this is the Reactive Workshop tutorial that I've downloaded to my machine from Activator. In here, we have a couple of folders. So where the code is in this app folder. You might not see it from back there, but it says app here. And then there are a couple of subfolders in here. Some of them I have created, like the price server. That's the provided price server implementation. And some of them are mandatory by Play, like controllers. Controllers should be in, or we prefer if you put your controllers inside of the controllers folder. Then there's a view, and that's where we put the views. And then there's a project folder as well. The configuration I told you about before is where you basically put all the configuration, how you want to wire up your application. So in here, for example, we have routes, which basically defines what URLs can be used to call the Play application. Right now, there's only a get, and that's for slash, if we call like localhost 9000, which this application will start at. Then it's going to call this index method, in controllers application index. And I'm going to go through this in detail later. Let me see if it's started up. No. Okay. Is there a cable I can use up here? Let's just continue in with the slides, and we can go back to these steps where we run. So as I told you, the Play routes is the configuration file where you want to configure all your URL mappings to your application. So basically, it's defined in your application or /conf/routes. And the way you define this is you use the HTTP verb, and then the path, and then the controller .method you want to call. And what's cool about this is that you can also extract parameters directly from the URL. If you look at the second line there, it says get person and then :ID, and then we, in controller application get person, we pass in this as a string. So you can already there get the actual type for it. So this is very powerful, and of course you can use post and put and whatever you delete. So this is where you start off when you build your Play application in the conf file. If we move on to the controllers, which you point to from your routes file, that's where you define what you want to happen in the method, what you want to reply back with. So in this case, we have the controller is called application. It's an object. Object in Scala is like a singleton. And it extends controller. Controller is something that we provide from Play. So that's referring to a Play class. It's extending the Play trait there. Scala, maybe I should walk through a little Scala syntax. Not many of you had done Scala before. So def here is where you define, that's a method. It's a method definition, and this method is called index. It doesn't take any parameters, and after the equals is what it's going to return. So we're going to return an action, and inside of that action, We're gonna wrap it inside of an action, and then we're gonna return this OK response back. So that's an HTTP 200, and we are going to render something. And in this case, we call index and then just pass in a parameter to that view that we're using. Passing in your application is ready, and that's going to be rendered in the view, and then we're going to return that view to the caller. And this is like this is how you define stuff. You wrap everything in actions, and then you can have multiple methods inside of a controller. You can, of course, have multiple controllers, too. Okay. So now I wanted you to create a controller in your application. That's not going to work. Let me see if this still works. That doesn't work. Yeah, that's too bad. Okay, I'm just going to have to show you how to do this then. Okay. So we want to create a controller called instrument controller in the controller package. And it's going to have a method called def_index. And it's just going to return h1 instruments here, that HTML command. And then we're going to render something, or we're going to render this response back. And we also need to amend the configuration file so it points to this controller we just created and method. And then start this and run it in Activator. Of course, Activator doesn't work, so I'm just going to do the source code now. So basically, the first step was to create this instrument controller. So let's create an object and extends controller. And then we wanted a method called def_index. We want to wrap that in an action. And then we wanted to say HTML something. Okay, HTML, H1, instruments, like that. Okay, so this is a functionality that we want to provide. Of course, it's really silly right now. It's just going to reply back. Whenever someone calls this route, it's just going to return instruments back. So that's the first step. This is the functionality. But to wire this up, we also need to make sure that we add it to the routes file. So we are going to wire this to start. So let's say start here. And you can see here that in controllers, then IntelliJ can provide me with the functional or the available functionality. So here it's pointing to instrument controller, and then I can use this index method. So when I run this, it means I can now point to two different URLs, either slash or start, and they are going to invoke two different controllers. But I don't think it works to run. This is bad. Can we verify that this works? Okay, yeah, here we go. Okay, so maybe now it actually started. That's good. Okay, so as you can see, when I ran, I used SPT, but SPT and Activator is substitutable, so I could have started this with said Activator run instead, which you can do if you want to. It now started the application the play application, and it says listening on port 9000. So then we can go over here and say local 9000. So local 9000 is just the first URL that we had. It's now going to compile the source code for me. You can see that it does something here. And if we go back, then it has rendered this view. This was the step 0 that you were supposed to do. So let's go back to that now that it actually runs. So here it says, welcome John Doe to the Reactive Instruments workshop. And if we look at the source code for this, I just called 9000, which invokes this controller method called index. So let's look at that. We went through this, and we passed in a parameter here called John Doe. So let's say JC here instead. I'm saving this in IntelliJ, and then I go back to my play application, and I just do a refresh. Am I doing this at the right place? Okay, so probably it's not running from where the source code is. Oh yeah, no it's not. This is probably pointing to somewhere else. Okay, let me jump over there instead. It's not going well today. So if we look at this controller, that's not the one I wanted. If we look at this controller, I have multiple projects, that's why. Okay, so if we look at this one, it still says John Doe, so let's change that to JC. Is this running? It's running. Okay, let's go back here. And now it's going to recompile this for me and change it to JC. The cool thing is that I can, so this is how you do, when you develop your play application, you have it running in the background. You just set it up, you have it running, and then you can just refresh, and the browser will automatically tell you if there's something wrong with this. So if we just say, I guess this template here expects a string, so if we do this, it's going to inform me that it couldn't compile this. There's a type mismatch between the integer that it found and the string that was required and the view. I'm going to show you what the view looks like later, but so you see it tells you immediately what's wrong in the application. So go back there and then refresh again, and then it works. Okay, so this was the step 1 that you were supposed to do. Now we created this other start view that just returned instruments. That's a H1, right? So that's there too. Of course, anything else, it just tells you, well, there's no action for that actually. Here's the routes file that has been defined. So it points to the different, or the expected URLs for you. So that's also helpful. Okay, yeah, that's right. Start is the one I wanted. So you go back to that one then. Okay, so maybe I should switch to the correct project. Okay. So we created this controller, and we changed the routes file to point to that controller. That's what we did in that step. And as you could see, I could refresh. I could refresh in the browser and basically get really good feedback in the browser for what was going on. Has anyone been able to start Activator at all? Yeah, okay, so a couple of you. That's good. Yeah, it's downloading a lot of dependencies. Okay, so that means, well, now I have internet connection at least, so we'll be able to go through all the different steps here. Has anyone got any questions so far in terms of routes or controllers? If you haven't, yes.
Yeah, a couple.
Can you walk up to the microphone?
Are you recording it or something?
I guess we're recording this, yes.
Oh, I guess it was a deliberate choice to do the compilation sort of on demand and present the errors in the browser as opposed to more the developer. Can you
Yeah,
talk about
yeah,
that?
this is like the developer mode.
I see. And then why is in the name of the view the HTML file? Why does it have Scala as part of the file?
Okay, yeah. So Scala, we're using Scala as that's the templating language because it's more powerful. So even if you use the Java version of Play, the templating language will be Scala or a Scala-like syntax. So that's the reason for that. So if you look at the view, and we're going to do that later, then there's some Scala code in there. But it's Scala, a Scala-like syntax. It's not like you have to use all of Scala in there. And yes, now we're running Play in developer mode, but you can also run in production mode where we'll compile everything up front. So it's yeah. Or I can repeat the question for you if you want to. Yeah.
So we have done like Play applications before. With this thing, do we not need Play anymore? Is it all self-encompassing?
With Activator, you mean?
Activator.
No, Activator is like, that's a tutorial tool that helps you. So with Activator, I mean, it didn't work very well now, but if you have a proper internet connection, then you have like 300 templates to choose from, and you can provide templates yourself. So this is a template I uploaded yesterday. And people upload, Akka clustered, and there's a template for that, or AngularJS. So Activator is more like an educational tool. You'll use Play under the hood. So you for your production environment, this is more like playing around with, and then you can develop in some real ID and have your Play application running there.